Welcome. In this video, we'll be looking at atomic radius and its associated periodic trends. If you're new to the channel, we do chemistry videos on general chemistry and AP chemistry. And in the previous video, we looked at ionization energy and its associated periodic trends. So if you're on that unit, if you're looking over those concepts, or if you're just preparing ahead, whatever the case is, that video could also be of interest to you, and I'll link it in the bio below. But let's get into this video. And start off with a definition. So atomic radius can kind of be defined as half the distance between nuclei in two identical atoms bonded together. So if I were to find the atomic radius of oxygen, per se, what I would do is I would get two oxygen atoms, bond them together, and then take the distance between the one nuclei and the other, which is going to be the diameter, and then half that to get the atomic radius. Now you may be asking yourself, why can't you just, get a normal oxygen atom and then kind of just take the radius like that? Well, the reason is that these circle boundaries out here are kind of undefined, right? They're not as explicit as a circle is. They are probabilities of where the electrons probably are. So it becomes very difficult to measure how far something is, what the radius of the atom is. So to kind of counter that effect, what they do is that they bond them together and then take the distance between the nuclei, which are a bit more easy to measure. And they half that, which becomes your atomic radius. All right. So then atomic radius are then measured in picometers. That's the unit of measurement, and 1 picometer is actually equivalent to 1 times 10 to the negative 12 meters, and that is a very, very, very small quantity. It's another reminder of how small of a scale these atoms and everything are operating in. So if you see PM when you're looking at atomic radiuses, these are the units that you use to measure them. All right, and before we look at the periodic trends for atomic radius, we need to explore one more concept of effective nuclear charge, which again, as I mentioned in the previous video, is an essential concept, essential to AP chemistry. And what it is the net positive, so it's a net positive charge experienced by electrons, or typically valence electrons. And what this kind of means is that the protons in the nucleus will exert a certain charge on the electrons, which keep it within the atom, right? The positive force of the nucleus, the negative force of the electron, that attraction, the stronger the positive force, the stronger the effective nuclear charge, and that is the relationship there. And that becomes very important when we're looking at the trends for atomic radius. The first trend is that atomic radius tends to decrease across the period. So from left to right, across the period, atomic radius will typically decrease. And the reason for this is due to effective nuclear charge. And we can kind of look at the example here. This is very similar to example to the ionization energy video. And you have lithium over here, which is on one end of the period, and you have neon over here on the other end of the period. So according to this trend, neon should have a lower atomic radius because it decreases, right? And the reason for this is because of effective nuclear charge. Now here, in lithium and neon, what's the same about both of these atoms is that the distance between the furthest electrons and the nucleus is the same, right? They both only have 2 electron shells each, right? That is, it's n equals 2 for both of them. They have the same distance. The only difference, however, is that neon has more protons, and as you go across the right to the periodic table, you add more protons. That's the atomic number increases, right? So as you go across the right, you're adding more positive charge, and what that does is that it actually adds more positive charge to the nucleus, and it decreases the effective nuclear charge experienced by the electrons. And what happens when this effective nuclear charge is increased, when there's more positive charge experienced by these electrons, they're going to come in towards the nucleus a bit more. And that effect will make the overall atom a bit smaller, right? Compared to this one where there isn't as much positive force, it's going to be larger. While in neon, there is 10 protons opposed to 3 protons, and they're all going to pull these electrons in a bit more, making this overall energy level a bit closer towards the nucleus. So that's the reasoning behind that trend. Hopefully that made sense. And the second trend is that atomic radius tends to decrease down a group. This one is a bit more self-explanatory, a bit more easy to understand, and here's some examples here. This is lithium, this is sodium, and this is potassium, I believe. And what's obvious, and this one's pretty obvious, is that as you go down each member of the group, a whole new shell is added, right? A whole new valence shell. This is n equals 4, this is n equals 3, this is n equals 2, right? And this adding of an entire new valence shell obviously increases the distance between the nucleus and the furthest electrons, right? So due to that, the effective nuclear charge is actually lower because the positive force is being, it's further away. There's less attraction being experienced. All right. And another phenomenon is also that the more electron shells you have, the more electron shielding there is, which basically is when these so here's what it is: electron shielding. Electron shielding, and what that is basically the inner electrons from the further electrons, they're gonna repel because light charges repel, right? So it's gonna push the electrons away. So the furthest electrons are actually going to be pushed away because there's this negative charge here, and it's going to keep repelling against each other and making it further and further from the nucleus. So that a phenomenon of electron shielding is also at play, along with the overall distance, which makes the effective nuclear charge lower, which lessens the attraction and makes the overall atom bigger. So that's the reasoning behind that trend. All right, one final thing. And this, I think, is a great test of understanding. And this is a graph that you will often see of the atomic radii of the first 40 elements, right? And a way to test your mastery, and I highly encourage that you do this, is to look at these charts, maybe make your own, maybe look at some online, and try to explain why the graph looks the way it does. And if you can do that, that means you have a good understanding of these trends. So the first trend, as we mentioned earlier, was that atomic radius decreases down a period. So how is that evident in this graph? Well, we can look at the second period over here. Lithium, right, is the first thing here, and it's the highest, right? Neon is the furthest to the right, so it's supposed to decrease this way, and it's the lowest. And everything else progressively gets lower, right? So that makes sense. That left to right, it decreases, and we can see that on the graph. And the same thing for sodium, argon. This trend is constant. So that's why, and that's the explanation for this trend you see on the graph here. All right, and the other trend is that atomic radius decreases down a group, and you can also see that here. If you look at the y-axis of this graph, this number of picometers goes up, right? So within each member of the group, so from lithium to sodium, it just went up a little bit, and from sodium to potassium, it went up about 50 picometers. And each successive member of a group, the atomic radius goes up in terms of value, the picometers. So that is the graph for atomic radii, and we just explained it using those trends. All right, so in this video, we looked at atomic radius, what it is, how we use it, we looked at effective nuclear charge and how we can explain atomic radius using that. And we looked at periodic trends, and we analyzed a graph. So hopefully you enjoyed the video. If you found it helpful, please click the like button, consider subscribing to the channel, and I hope to see you all next time.